Welcome to the fascinating world of text mining. In our digital age, we're surrounded by massive amounts of text data, from emails and social media posts to news articles and business documents. But how do we make sense of all this information? That's where text mining comes in. Text mining is the process of extracting meaningful insights and patterns from unstructured text data. It helps organizations and individuals turn raw text into valuable knowledge, enabling smarter decisions and deeper understanding. In this video, we'll explore one of the most important techniques in text mining, text classification. Let's dive in and see how it works. Text classification is a core task in text mining. It involves automatically assigning predefined categories or labels to pieces of text, such as emails, reviews, or articles. Imagine sorting thousands of customer feedback messages into topics like product quality, delivery, or customer service. That's text classification in action. This process saves time, reduces manual effort, and helps businesses quickly identify trends or issues. Whether it's spam detection, sentiment analysis, or topic labeling, text classification is everywhere in our daily digital interactions. Importance of text classification can't be overstated. With the explosion of digital content, organizations need efficient ways to organize and analyze text data. Text classification enables automated sorting, making it easier to manage large volumes of information. For instance, news agencies can categorize articles by topic, while companies can filter customer emails by urgency. This not only streamlines workflows but also enhances decision-making by providing quick access to relevant information. Text classification is used in a wide range of applications. Email providers use it to filter spam, social media platforms use it to detect hate speech, and businesses use it to analyze customer feedback. In healthcare, it helps categorize medical records, while in law, it assists in sorting legal documents. The versatility of text classification makes it a valuable tool across industries, helping organizations extract actionable insights from unstructured data. There are two main approaches to text classification: supervised and unsupervised learning. In supervised learning, models are trained on labeled data, meaning each text example has a known category. This allows the model to learn patterns and make predictions on new, unseen data. Unsupervised learning, on the other hand, doesn't rely on labeled data. Instead, it finds hidden structures or groupings within the text. Both methods have their strengths and are chosen based on the problem at hand. Supervised learning is the most common approach in text classification. Here you start with a dataset where each text sample is already labeled with the correct category. The model learns from these examples, identifying features and patterns that distinguish one category from another. Once trained, the model can classify new unlabeled text with impressive accuracy. This method is widely used for tasks like spam detection, sentiment analysis, and topic categorization. Supervised learning takes a different approach. Instead of using labeled data, it looks for patterns and groupings within the text itself. Clustering algorithms, for example, can group similar documents together based on their content. This is useful when you don't have predefined categories or when exploring new topics in large datasets. Unsupervised learning is often used for topic modeling and discovering hidden themes in text collection. Text classification typically follows a series of key steps. First, you collect and prepare your text data. Next, you clean and preprocess the text, removing noise and standardizing formats. Then you extract features that represent the text in a way the model can understand. After that, you train your classification model using either supervised or unsupervised methods. Finally, you evaluate the model's performance and fine-tune it for better result. First step in any text classification project is data collection. This involves gathering text data from various sources, such as emails, social media, websites, or internal documents. The quality and quantity of your data play a crucial role in the success of your classification model. It's important to ensure that your dataset is representative of the categories you want to classify, and that it covers a wide range of examples. Once you've collected your text data, the next step is preprocessing. This means cleaning the text by removing irrelevant information, correcting errors, and standardizing formats. Common preprocessing tasks include removing stop words, punctuation, and special characters, as well as converting all text to lowercase. Proper preprocessing ensures that your model focuses on the most important information and isn't distracted by noise. Tokenization is a fundamental step in text preprocessing. It involves breaking down text into smaller units called tokens, which are usually words or phrases. By splitting the text into tokens, we make it easier for the model to analyze and understand the content. Tokenization lays the groundwork for further processing, such as feature extraction and model training. Stop words are common words like the, is, and that don't carry much meaning in text analysis. Removing stop words helps reduce noise and allows the model to focus on the most relevant terms. This step is especially important in tasks like sentiment analysis, where the presence of certain keywords can significantly impact the results. Stemming and lemmatization are techniques used to reduce words to their base or root form. For example, running, runs, and ran can all be reduced to run. This helps the model treat similar words as the same, improving classification accuracy. While stemming is a simpler, rule-based approach, lemmatization uses vocabulary and grammar rules for more accurate results. After preprocessing, the next step is feature extraction. This involves converting text into numerical features that a machine learning model can understand. Common techniques include bag of words, TF-IDF, and word embeddings. Feature extraction transforms raw text into structured data, making it possible to apply powerful algorithms for classification. Bag of words model is a simple yet effective method for feature extraction. It represents text as a collection of individual words, ignoring grammar and word order. Each word is assigned a value based on its frequency in the document. This approach is easy to implement and works well for many text classification tasks, especially when dealing with large datasets. The FIDF, or Term Frequency Inverse Document Frequency, is another popular feature extraction technique. It measures how important a word is to a document relative to a collection of documents. Words that appear frequently in one document but not in others get higher scores. This helps highlight unique and meaningful terms, improving the performance of classification models. Word embeddings are advanced feature extraction methods that represent words as dense vectors in a continuous space. Unlike bag of words or TF-IDF, embeddings capture semantic relationships between words, such as similarity and context. Techniques like Word2Vec and GloVe have revolutionized text classification by enabling models to understand the meaning behind words, not just their presence. Features extracted, it's time to choose a classification algorithm. Popular choices include naive Bayes, support vector machines, decision trees, and deep learning models like neural networks. The choice depends on the size of your dataset, the complexity of the task, and the desired accuracy. Each algorithm has its strengths and trade-offs, so it's important to experiment and find the best fit for your project. Naive Bayes is a simple yet powerful algorithm for text classification. It's based on probability theory and assumes that features are independent of each other. Despite its simplicity, Naive Bayes often delivers strong performance, especially for tasks like spam detection and sentiment analysis. It's fast, easy to implement, and works well with large datasets. Support vector machines, or SVMs, are another popular choice for text classification. SVMs work by finding the best boundary that separates different categories in the feature space. They are known for their accuracy and ability to handle high-dimensional data, making them suitable for complex classification tasks. However, they can be computationally intensive for very large datasets. Decision trees are intuitive algorithms that split data into branches based on feature values. Each branch represents a decision rule, leading to a final classification at the leaves. Decision trees are easy to interpret and visualize, making them a popular choice for beginners. However, they can be prone to overfitting if not properly managed. Deep learning models, such as neural networks, have transformed text classification. These models can capture complex patterns and relationships in text, leading to state-of-the-art performance. Techniques like recurrent neural networks, RNNs, and transformers are especially powerful for tasks involving context and sequence, such as sentiment analysis and language translation. Once you've chosen your algorithm, it's time to train the model. Training involves feeding the model labeled examples and allowing it to learn the patterns that distinguish each category. The quality of your training data and the choice of features play a big role in the model's performance. Training can take anywhere from a few seconds to several hours, depending on the complexity of the model and the size of the dataset. After training, it's crucial to evaluate your model's performance. Common evaluation metrics include accuracy, precision, recall, and F1 score. These metrics help you understand how well your model is classifying text and where it might need improvement. Evaluation is typically done using a separate test set that the model hasn't seen before, ensuring unbiased results. If your model isn't performing as well as you'd like, there are several ways to improve it. You can collect more data, try different preprocessing techniques, or experiment with new features. Tuning model parameters and using advanced algorithms can also boost performance. The key is to iterate and test different approaches until you find the best solution for your specific task. In many real-world scenarios, some categories may have much more data than others. This is known as imbalanced data and can lead to biased models. Techniques like oversampling, undersampling, and using weighted loss functions help address this issue. Properly handling imbalanced data ensures that your model performs well across all categories, not just the most common ones. Cross-validation is a technique used to assess how well your model generalizes to new data. It involves splitting your dataset into multiple parts, training the model on some parts, and testing it on others. This process is repeated several times, and the results are averaged to provide a more reliable estimate of model performance. Cross-validation helps prevent overfitting and ensures your model is robust. Once you're satisfied with your model's performance, it's time to deploy it. Deployment means integrating the model into a real-world application, such as a website, mobile app, or business workflow. This allows users to benefit from automated text classification in their daily tasks. Monitoring the model's performance after deployment is important to ensure it continues to deliver accurate results. Let's look at a real-world example: spam detection in email. Text classification models are trained to distinguish between spam and legitimate emails based on features like word frequency, sender information, and message structure. Once deployed, these models can automatically filter out unwanted messages, saving users time and reducing the risk of phishing attacks. Sentiment analysis is another popular application of text classification. Businesses use sentiment analysis to gauge customer opinions by classifying reviews or social media posts as positive, negative, or neutral. This helps companies understand customer satisfaction, identify areas for improvement, and respond to feedback more effectively. Topic labeling involves automatically assigning topics to documents, such as news articles or research papers. Text classification models analyze the content and determine the most relevant category, making it easier to organize and search large collections of documents. This is especially useful for libraries, news agencies, and academic institutions. Despite its many benefits, text classification comes with challenges. Language is complex and constantly evolving, making it difficult for models to keep up. Ambiguity, sarcasm, and context can all impact classification accuracy. Additionally, dealing with large, noisy datasets requires careful preprocessing and feature engineering. Overcoming these challenges is key to building robust text classification systems. Ambiguity in language can make text classification tricky. Words often have multiple meanings depending on context. For example, the word bank could refer to a financial institution or the side of a river. Advanced models use context and surrounding words to disambiguate meanings, but this remains a challenging aspect of text mining. Sarcasm and irony are particularly challenging for text classification models. These forms of expression often mean the opposite of what the words say, making it hard for algorithms to interpret sentiment accurately. Researchers are developing new techniques such as context-aware models and sentiment analysis tools to better handle these nuances in language. As the volume of text data grows, scaling text classification models becomes essential. Efficient algorithms, distributed computing, and cloud-based solutions help process large datasets quickly and accurately. Scalability ensures that text classification remains effective even as data volumes increase, supporting real-time applications and big data analytics. Ethics play an important role in text classification. Models can inadvertently learn biases present in the training data, leading to unfair or discriminatory outcomes. It's crucial to monitor and address bias, ensure transparency, and respect user privacy. Responsible use of text classification helps build trust and promotes positive outcomes for all users. Text classification models need regular updates to stay effective. As language evolves and new data becomes available, retraining and fine-tuning the model ensures it remains accurate. Continuous improvement is a best practice in text mining, helping models adapt to changing trends and user needs. Future of text classification is bright, with ongoing advances in artificial intelligence and natural language processing. Emerging techniques like transformer models and transfer learning are pushing the boundaries of what's possible. These innovations promise even greater accuracy, speed, and versatility, opening up new opportunities for text mining across industries. Transfer learning is a powerful technique where models trained on large datasets are fine-tuned for specific tasks. In text classification, this means leveraging pre-trained language models like BERT or GPT to achieve high performance with less labeled data. Transfer learning has made advanced text classification accessible to more organizations, even with limited resources. As text classification models become more complex, explainability is increasingly important. Explainable AI techniques help users understand how and why a model makes certain decisions. This transparency builds trust and allows for better debugging, especially in sensitive applications like healthcare or finance. Text classification doesn't operate in isolation. It's often integrated with other systems such as chatbots, recommendation engines, or business intelligence platforms. Seamless integration allows organizations to automate workflows, enhance user experiences, and gain deeper insights from their data. With globalization, text classification models must handle multiple languages. Multilingual models and translation tools enable classification across diverse datasets, supporting international businesses and cross-cultural research. Handling different languages adds complexity, but also expands the reach and impact of text mining solutions. User feedback is invaluable for improving text classification models. By monitoring how users interact with the system and collecting feedback on classification results, developers can identify areas for improvement. Regular updates based on real-world usage help maintain model relevance and accuracy over time. Let's recap what we've learned about text classification and text mining. We explored the basics of text classification, key steps like preprocessing and feature extraction, and popular algorithms. We also discussed real-world applications, challenges, and future trends. Text classification is a powerful tool for making sense of unstructured data and unlocking valuable insights. Thank you for joining us on this journey through text classification and text mining. As you've seen, this field is rich with opportunities and challenges. Whether you're a beginner or an experienced practitioner, there's always more to learn and explore. Keep experimenting with new techniques, stay updated on the latest trends, and continue unlocking the power of text data in your projects.